Hi everyone, today we'll be solving question number 7 from the 2012 Euclid Math Contest. In the diagram, triangle ABC has length AB equal to AC and angle BAC is less than 60 degrees. Point D is on AC with BC equal to BD. Point E is on AB with BE equals to ED. If angle BAC is equal to theta, determine angle BED in terms of theta. First, since length AB equals to AC, this is an isosceles triangle. So triangle ABC is isosceles. So here. And angles ABC and ACB will be the same. So I'm going to give them the variable x. So here and here. And since all angles in the triangle add up to 180, in terms of theta, x plus theta is equal to 180. And next, 2x equals to 180 minus theta. And x equals to 90 minus theta over 2. And now we also know that length BC is equal to length BD. So triangle BCD is isosceles too. So angle BDC will also be x. And triangle BED is also isosceles too, since length BE is equal to length ED. Oops. Just gonna label that BC is equal to BD. Now I can make an equation for angle DBC, which I'm going to label as Y. So this small angle here is going to be labeled as Y. So Y equals to 180 minus 2x. Since 180 is all of the angles in triangle BCD combined, summed up together, and 2x are these two angles here. And angle EBD, which I'm going to label as Z, is equal to x minus y. So angle Z is equal to x minus y. So it's this one minus this. Let's label this here. So now I can substitute the y values to make an equation for angle EBD, which is angle Z. So angle Z equals to x minus 180, don't forget the brackets, minus 2x. Next we're going to simplify, and now we end up with angle Z equals to x minus 180 plus 2x, which equals to 3x minus 180. Which equals to angle Z. After that, since triangle BED is an isosceles triangle, angles EBD and EDB are the same. So this can also be angle Z. And we can use that information to find angle BED. So angle BED is equal to 180 minus 2z, which is this angle here. Since we already figured out the equation for z, which is 3x minus 180, so this is the equation of angle z. And we can plug it into this equation to find angle BED. So angle BED is equal to 180 minus 2 times 3x minus 180. Then we can simplify and we get 180 minus 6x plus 360. And finally, 180 plus 360 is 540. So 540 minus 6x is equal to angle BED. Finally, we can use the equation we found at the beginning to plug it into this equation. And as you can recall, x is equal to 90 minus theta over 2. So so angle BED is equal to 540 minus 90 minus theta over 2. And I almost forgot the 6. So there's a 6 here. And simplifying, it's 540 minus 540 plus 3 theta. And the two 540s cancel out, so after simplifying the final equation, we find out that angle BED, so angle BED is equal to 3 theta. And that is our final solution. Part B of the question states that in the diagram, the Ferris wheel has a diameter of 18 meters and rotates at a constant rate. When Kalapo rides the Ferris wheel and is at its lowest point, he is 1 meter above the ground. When Kalapo is at point P that is 16 meters above the ground and is rising, it takes him 4 seconds to reach the highest point, T. He continues to travel for another 8 seconds, reaching point Q. Determine Kalapo's height above the ground when he reaches point Q. First, I can assume that the tip of the triangle right here is at the center of the circle, which I labeled as C, right here, as a dot in the center. Then I drew some lines going from the center to points P, T, and Q. I also drew a line that goes opposite to point P and one from the center to that point. Now, since the diagram states that the diameter of the circle is 18, we can figure out that the radius is 9. So it's right here. Diameter is 18. And we found the radius by dividing it by 2. So every line that we draw from the center to the circumference is 9 in length. So let's label that. So 9, 9, 9, and 9. We can also see that from the top of the circle to the bottom is 19 in length. So here to here, 18 plus 1, 19. Then we can also notice that this small segment right here will be 3 meters because it's 19 minus 16. And this will be 6 because 9 minus 6. Next, we can use trigonometry to solve for this angle theta. This angle theta. Since this is a right angled triangle right here. So I can label that. So cosine of theta is equal to 6 over 9. Which is also equal to 2 over 3. We'll come back to that later. Now, because the rotation of the Ferris wheel is constant, the time it takes to move from T to Q is double of P to T. Therefore, the angle subtended by arc TQ is 2 theta. If we divide it among these two triangles, this is theta, because it's a reflection of this triangle, and this will also be theta. Now let's find the height when Kalapo is at point Q. So we have to draw one more triangle in order to do that. So first, I'm gonna put a line here that goes from center to the bottom line. And then this line that's perpendicular to that line and goes to point Q. This triangle can help us, this small triangle right here can help us figure out the distance from Q to the bottom. So that's this. So let's first find the length of the center to the bottom line. So the top of the Ferris wheel is 19 and T to the center is 9. So let's see. So 19 minus 9 is 10. So this will be, this will be 10. This line. And now I need to figure out this distance right here, which I can label as x, and subtract it from 10 to get my final answer. So my answer will be 10 minus x, whatever x will be. And that is the same as going from Q to the bottom line. And finally, I can use trigonometry again to solve for this angle, which is, I'm going to label as y. Since this small triangle has a right angle, so 180, which is this whole angle, 180 minus 2 theta is equal to y. And so now I can figure out the distance. I can form an equation to solve for it. So cosine, it's right here, cosine of 180 minus 2 theta, which is this angle y, is equal to x adjacent over hypotenuse, so x over 9. Now I can use some double angle identities to solve this. The first one I'm going to use is cosine of alpha minus beta is equal to cosine of alpha cosine beta plus sine alpha sine beta. If we apply that equation to here, it will be cosine of 180 times cosine of 2 theta plus sine of 180 times sine of 2 theta, which equals to x over 9. And now I can simplify this. So sine 180 is 0. So then this part cancels out. Cosine of 180 is -1. So we are left with minus cosine of 2 theta is equal to x over 9. And now the second double angle identity that I'm going to use is cosine of 2 theta is also equal to 2 cosine of theta squared minus 1. If we use that here, we'll get minus 2 cosine squared theta minus 1 equals to x over 9. And if we simplify the bracket, minus 2 cosine theta squared plus 1 is equal to x over 9. And now I can substitute this equation from the beginning, which was cosine of theta is equal to 2 over 3. You see cosine of theta is right here. So if we plug that in, minus 2 and cosine of theta squared is 2 over 3 squared plus 1 equals to x over 9. Simplifying that, 2 squared 4 over 9 times 2 minus 8 over 9 plus 1 is equal to x over 9 plus 1. And now I can simplify this, so minus 8 over 9 plus 1 is 1 over 9 is equal to x over 9. Multiply both sides by 9 and we get x is equal to 1. And now we figure out the x value, x equals to 1. We can now plug it back into this equation, which represented Kalappo's height to the bottom of the ground here. So x is 1, so 10 minus 1 is equal to 9. And that is our final solution. So our final answer is 9 meters.